Hi friends, welcome to our lesson. I'm Mrs. Gradney, and today in our lesson, we'll be exploring angles. Here's what you'll need for our lesson today. Let's get started. We're going to start by creating a tool to help us explore angles. So first, grab your white circle and draw a circle around the center point, just like you can see on mine. The circle doesn't have to be perfect, but it's going to help us to see the angles better on the tool we're creating. Now we're going to put our circles together. Watch how we'll do that. Hold your red circle in your left hand and your white circle in your right hand with the slits facing each other, and then just kind of slide them together where those slits will overlap, just like that. And boom, we have our tool. Now we're going to use our tool to explore angles. First, make sure that this bottom segment on the red circle is parallel to the edge of your desk. And now to make angles, we're actually going to pinch the white circle, and we can turn that to the left, or we can turn the white circle to the right. And if it comes apart, it's no big deal. You just slide them right back together. Okay, now take a look at our circles. Do you see any angles? Yeah, we can actually see a couple of angles. We can see that this white region makes an angle. It's clearly marked with this arc. But guess what? This red part also makes an angle, this angle here. So let's agree that the angles that we're going to be focusing on in our tool are the white angles, the one that's marked with an arc. We can make our angles larger by turning the white circle to the left, and we can make our angles smaller by turning the white circle to the right. So if this is our angle here, where's the vertex? Right, the vertex is the center of the circle. And where are the rays? The rays are these dark segments where the white and the red circles meet. Great. So let's make some angles. Make an angle with me. Make this one. What kind of angle did we make? It's an acute angle. Great. Let's make another one. What about this one? And what kind of angle is it? It's an obtuse angle, right? What about, remember you're making the angles with me. What about this one? It's a right angle. And let's do one more. What about this angle? It's a straight angle. Way to go. Now let's make our tool show no angle. So turn that white circle to the right until it's all red. Now we have no angle. Now turn with me. Let's make a quarter turn to the left. So remember, pinch that white circle, make a quarter turn to the left. It doesn't have to be perfect. Now, what fraction of the circular region is white? 1/4 of the circular region is white. Let's make another quarter turn to the left. What fraction of the circular region is white now? 1/2 or 2/4 of the circular region is white. If we were to cut out the angle represented by the white region, what fraction of the circle would we cut out? 1/2 or 2/4 of the circle. Great. Let's make another quarter turn to the left. What fraction of the circular region is white now? 3/4 is white. And let's make another quarter turn to the left. What fraction of the circular region is white now? It's all white, huh? 4/4 of the circular region is white. That made one full turn. How many fourth turns did it take to make one full turn or one full circle? It took 4 fourth turns to make one full turn or one full circle. Way to go. Now let's go back to making our circles show no angle. So we'll have to put them back together. And then turn that white circle to the right until we show a no angle. Great. Now I want to break up the whole circle or a full turn into 8 equal parts. First, let's count by eighths. Ready? 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Now, think about what you know about fractions. Would a 1/8 turn or 1/8 cut from the circle be less than or greater than 1/4 turn or 1/4 cut from the circle? Pause the video to think about that and explain what you're thinking. 1/8 turn or 1/8 cut from the circle would be less than 1/4 turn or 1/4 cut from the circle. We know that because we know 1/8 is less than 1/4. In fact, a 1/4 turn would be equal to 2/8 turns. Show me what you think a 1/8 turn would look like on your circles. I was thinking a 1/8 turn would be about halfway to a 1/4 turn, so maybe something like that. Now let's go back to showing no angle. And now as I say the fractions, I want you to show me that fraction cut from the circle. Ready? 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Great job. So, did it take more fourth turns or fourths cut from a circle, or more eighth turns or eighths cut from a circle to make the full turn or the full circle? It took more eighth turns. And how many eighth turns did it take to make the full circle? Or to ask another way, how many eighths could we cut from the full circle? 8/8. Way to go. Now think about this. How many hundredth turns would be in a full turn? Or how many hundredths could we cut from a full circle? Right, 100. Show me what you think 1/100th of a circle would look like. I was thinking 1/100th of a circle would be pretty small. Smaller, maybe something like that. Now, would 1/360th turn or 1/360th cut from a circle be less than or greater than 100th turn or 100th cut from a circle? It would be less than. It would be even smaller than 100th turn. And guess what? We have a special name for 1/360th of a full turn or 1/360th cut from a circle. It's called a degree. Everyone say degree. How many degrees are in a full turn or in a full circle? 360 degrees are in a full circle. Nice job. Now take a look at this tool, which has been partitioned and marked off to show 360 degrees. Just like we have tools to measure length and weight, right? We can use a ruler to measure how long something is in centimeters or inches. And we can use a scale to measure how much something weighs in grams. We have a special tool to measure the size of angles. It's called a protractor, and this is an example of one. What's it called? A protractor. The degree measure of an angle is measured with a protractor. Pause the video and take a moment to analyze this protractor and talk about what you notice. You probably noticed that this protractor is shaped like a circle. If you looked more closely at the numbers, you may have noticed that it counts by 10, from 0 all the way up to 350. There are tick marks between the 10s to show the 1s. So there are 10 more degrees after the 350, so this protractor really shows 360 degrees. The 360 just isn't labeled. That makes sense because we just learned that a full circle has 360 degrees in it. You may have also noticed that there is a set of perpendicular lines in the center. So that makes 4 right angles. Great observations. Now run your finger from 0 across this line to the center point where these perpendicular lines cross. Let's call this our 0 line or our baseline of the protractor because this will be the starting point from where we measure angles. Now we need our angle tool again, so grab that and put them back together if they're not together, and show me a quarter turn. Make sure that the bottom segment of your red circle is parallel with the edge of your desk. Okay, that looks like about a quarter turn. Okay, now we want to make it more precise. So let's use our right angle template to make it more precise. We're going to take our right angle template and lay it on top of our circles and match it up. So I'm going to match up this bottom segment with the bottom, and then the top segment, oh, I can see it's a little bit off. So I'm going to move my circles. Try again, see if it matches up. And it matches up precisely. Once you have your right angle template matched up with your angle, go ahead and move your right angle template. And what kind of angle is this? It's a right angle. Very good. Now let's use our protractor to find the degree measure of a right angle. So grab your protractor and we're going to set it on top of our circles. Now when we set it on top of our circles, remember this is our baseline, our zero line, where we're going to start to measure the angles, where it's 0 degrees. So we want to make sure that this line lines up with the bottom segment of our angle. Now we can't see through our protractor, so we just have to do the best that we can. But like for example, if my protractor was like this, I can tell that that's not really lined up with my baseline. So I'm going to line it up like that. And we also want to make sure that the center point is lined up with the vertex of the angle. Again, we can't see through the protractor, but for example, I can tell that the center point is not aligned with the vertex because I can see this up here is not lined up. So I'm going to line it up. There we go. And what do you notice? This side of the angle says 0 degrees, and the other side is lined up with 90. So that means the degree measure of this angle is 90 degrees. 1/4 cut from 360 degrees is 90 degrees. So what's the degree measure of a right angle? It's 90 degrees. Nice. Let's make another quarter turn to make a half turn and then measure it. Remember to line up that baseline with your segments. So what's the degree measure of a half turn? 180 degrees. So how many degrees are in 1/2 cut from a circle? 180 degrees. Why does that make sense? Pause the video to talk out your thinking. It makes sense that 1/2 turn is 180 degrees because 1/4 turn is 90 degrees. It takes 2 quarter turns to make 1/2 turn. 90 plus 90 equals 180, so it just makes sense. Let's make another quarter turn and measure it. What's the degree measure now? 270 degrees. Let's make one more quarter turn. What does the angle look like now? It's all white. We made the full circle. Let's measure the angle. What's the measure of this angle? Some of you may have said 0 degrees because we see the 0 mark here. But remember, a 0 degree angle means that we haven't turned at all. Here, we've made the full circle. We've turned the full 360 degrees. So the measure of a full circle, a circle with nothing cut out of it, is 360 degrees. How many right angles are there in a full circle? And how do you know? There are 4 90-degree angles in a full circle. We just made 4 quarter turns, which is the same as 4 1/4 cutouts of a circle, and each one was 90 degrees. Excellent work today, friends. I think we're ready for our assignment. Our assignment this time comes from the homework pages, and the suggested problems are on the screen. Work on these problems for 10 minutes. Today,